What's up, y'all? Pastic here, and in this video we are going to continue to solidify the connection between a function and its derivative, as well as look specifically here at the graph of an original function f of x, and use that graph of the original function f of x to answer questions about its derivative f prime of x. So let's do it. So the first problem here wants us to approximate the value of f prime of 4. So that's asking for the value of the derivative at x equals 4, which is the same as asking for the slope of the tangent line drawn to the original graph at x equals 4. So if I look over here at this graph, this is about right here where the graph equals 4, right about there. And there isn't a really nice set point there, so if I even were to draw the tangent line, I probably wouldn't have a great idea of how to draw the tangent line exactly. I could kind of eyeball it, but what we'll do instead is, instead of looking for the exact slope of the tangent line, we'll look for the slope of the secant line drawn between the 2 points next to it. So since we're looking for 4, we're going to use the 2 points next to it, which are x equals 3 and x equals 5. We're going to draw this secant line right here. And we're going to use the slope of that line to approximate the value of f prime of 4. So it looks like the points are 3, -1, and 5, 4. So I'm going to find the slope of the line going through those 2 points. So I have found that the slope of this secant line is approximately 5/2, which will be, in this case, a good approximation for f prime of 4. Okay, so the next one says, at what values of x is f prime of x equals 0? So f prime of x equals 0 means the derivative equals 0. If the derivative equals 0, that's the same as saying the tangent line slopes equal 0. So where would I draw tangent lines that have slopes of 0? So I can see one here. That looks like one. I can see one here. That looks like one. And I can see one here. Those 3 locations are going to have a tangent line that has a slope of 0. So those are the 3 locations where f prime of x equals 0. So I'm going to write that out. So what I've written is that f prime of x equals 0 when a smooth curve f of x changes from increasing to decreasing or vice versa. Those are the places where the tangent lines will be horizontal. This is a very important detail here, which will be discussed later on in calculus, but for now, let's just make sure we write that, and eventually we'll learn why. It has to do with differentiability. So therefore, f prime of x is equal to 0 when x equals -4, 1, and 5. So the next part says, on what open interval is f prime of x less than 0? The derivative will be less than 0 when the slopes of the tangent lines are negative. The slopes of the tangent lines of the original function will be negative when the original function is decreasing. So let's look at where this function is decreasing. It's decreasing from here to here, and from here to infinity. So I'm going to write that f prime of x is less than 0 on those red intervals, and I'll be right back. Okay, so I've written my answer as f prime of x is less than 0 on -4, 1, union the open interval 5 to infinity, because on these intervals f of x, the original function, is decreasing. Perfect. So the next question is basically the complement to that. It's on what open interval is f prime of x greater than 0? Well, this is going to happen whenever f of x is increasing. So f of x is increasing from -infinity to here, and from +1 to, looks like, 5. So I'm going to go ahead and write my answer to describe those 2 intervals, and I'll be right back. So I've written f prime of x is greater than 0 on on the open interval from -infinity to -4, union the open interval from 1 to 5, because on these intervals f of x, the original function, is increasing. On to the next 2 questions. At what values of x does the graph f prime of x go from being below the x-axis to above the x-axis? So below the x-axis would mean that the derivative is negative. above the x-axis would mean where the derivative is positive. So where does the derivative go from negative to positive? That's what I want to take a little note on. So I've written a little note for myself. The f prime of x goes from negative to positive. The derivative is going to go from negative to positive whenever the original function goes from decreasing to increasing. So where does this original curve go from increasing to decreasing? That's what we want to ask ourselves. So I'm looking at decreasing to increasing. I don't know if I said that right. So I want to make sure we want to look for where the original curve goes from decreasing to increasing, because that'll be where the derivative goes from negative to positive. So the only place where I see that happening is right here. I see this going from decreasing to increasing right here. And that happens right here at this point, at x equals 1. So I'm going to go ahead and write my answer. So I've written that f prime of x goes from below the x-axis to above the x-axis at x equals 1, because at this value, f of x, the original function, goes from decreasing to increasing. And then the last one is kind of the opposite question. It's kind of the complement question. It says, where does the graph of f prime of x go from being above the axis to below the axis? So that means we're looking for where does the original function go from increasing to decreasing. So it switches from increasing to decreasing right here and right here. So I'm going to write my answer, and I'll be right back. So I've written f prime of x goes from above the x-axis to below the x-axis at x equals negative 4 and 5, because at these values, the original function f of x goes from increasing to decreasing. All right, so hopefully we're getting a little bit more solid understanding of the connection between the original function and the derivative. That's it for me. I'll catch you all next time.